Hi viewers, hope you are all doing great. In this video, I'm going to show you a simple way of solving problems related to Gay-Lussac's law and Avogadro's law. I discovered that students are finding it difficult to solve problems related to these two laws under that laws. First and foremost, let's state Avogadro's law. You all know that Avogadro's law states that equal volume of all gases at the same temperature and pressure contain the same number of molecules. For example, if I have something like this, from this question now, I have hydrogen gas, then I have oxygen gas. So if these two gases react together, then we are going to have two molecules of water. How do you know that it's going to be two molecules of water? If ideally you're going to have water as your product, isn't it? So you have hydrogen gas, oxygen gas reacting together to form water. Okay, we have hydrogen to be two molecules here, or hydrogen to be two. We have two hydrogen here, we have two hydrogen. We have one oxygen here, two oxygen here, we have one here. So if you have two here, so this will be two oxygen, four hydrogen. That means you're going to have two here to make it balanced. Now, so what this Avogadro law is saying is that equal volume of all gases at the same temperature and pressure contain the same number of molecules. So now, these molecules that we have here, these 2 moles of hydrogen must react with 1 mole of oxygen before we can form 2 molecules of water. So which means that if you react just 1 mole of hydrogen gas plus 1 mole of oxygen gas, you will not get water. So which means that it must be 2 molecules of hydrogen gas that will react with 1 mole of oxygen gas that will give you water. That's what the law is talking about. Alright, the second law, which is Gay-Lussac's law, states that when gases react, like these two gases, when they react, they do so in volumes. So this one now is 2 volumes, this one is 1 volume, this one is 2 volumes. You understand? They do so in simple ratio to one another. Okay, they do so in volumes which are in simple ratio. So this is this ratio as well. This is 2 ratio 1 and ratio 2. You understand? So now with this, we all agree that this is going to be the balance equation for the reaction between oxygen gas and hydrogen gas. Alright, having know that, the next thing we are going to do now is that we are going to use the volumes given to us from the question. So what we do now is that, since we've been told that hydrogen is 1000 cm cube of hydrogen, so that means hydrogen is 1000. So if hydrogen is 1000 and we were told that 300 cm cube of oxygen, so that means here will be 300. So now if there is 300, you agree with me that for the number of oxygen that we have here, it is smaller than that of the oxygen. You understand? So which means that if we divide this oxygen by 1, which is the number of mole of oxygen here, or 1 volume, we are still going to have 300. Isn't it? 300. And the 300 times 2 molecules of hydrogen gas will give us 600. Then 300 times 2 of this molecule of water, we still have 600. You understand? So now let's subtract for the number of hydrogen that is exploded. Let's check. 1000 minus 600 will give us 400 cm cube. So 400 cm cube is the volume of hydrogen that will be left over. You understand? So when you subtract this, you're going to have something like that. Sometimes they may ask you to also calculate the volume of the resulting gas or the resulting compound. The resulting compound is water, so which is 600 cm cube. Or if you ask to calculate the residual or volume of the residual gases, so that means you're going to add 400, which you have gotten for hydrogen, that is the leftover, plus that of the resulting mass, which is 600. So that will give you 1000 cm cube. Watch out for the next episode of this lesson. Bye.